So part 2 of lesson 4, we're going to go back and talk about, we're going to revisit this idea of functions being even and odd, because that's going to help us. This is going to give us another tool for evaluating trig functions of negative angle measures. So let's go back and revisit an old friend, the quadratic. So is the function f of x equals x squared an even function or an odd function? So I'm hoping that you're saying it is an even function, Mrs. Gribble, and you're right. And you might tell me that it's an even function because there is symmetry. The graph of this function has symmetry with respect to the y-axis, so we know it looks like this, and there's symmetry. If I wanted you to show or determine whether or not the function x squared is even or odd algebraically, then we might approach it this way. Remember how we took everywhere we had an x, we substituted the opposite of x and evaluated the function at negative x. So when you take a negative and square it, you end up with a positive and x squared. So f of negative x is x squared, which is the exact same as f of x. So because f of negative x equals the exact same f of x, then we know that this is an even function. Okay, and we talked about that in our very first unit. Let's talk about another function, f of x equals 4x. Let's determine if it's an even function or an odd function, or neither. I guess I could put that in there. Well, if we take a look, if we recall what the graph of this looks like, this is going to be linear. Its y-intercept is going to be at the origin. It's going to be, fairly steep because the slope is 4. So you might be able to look at that and say, oh, okay, there's this particular function is an odd function, and it is. But let's talk about how we would show that algebraically. So once again, to determine if a function is even or odd, we would substitute into the function negative x, or the opposite of x, which is negative x. So now when we simplify this, we see that f of negative x equals negative 4x. And if you compare negative 4x with what f of x was, then you'll see that these are the exact opposite. And because these two functions are exact opposites, then we know that this is an odd function. Okay? And if you recall, odd functions have symmetry with respect to the origin. So, odd, opposite, origin. That's how I remember the information about odd functions. So in general, a function that is odd, when you substitute f of negative x, you will get the exact opposite of what you had for f of x. Keyword opposite. So now I want to transfer that information to the trig functions. And you may not be aware of what the graph of a trig function looks like. So let's just do that. So you don't have to pull your calculator out with this, but I'm going to, I want to graph the function cosine of x. So I'm going to clear out what I have, y1, and in y1 I'm going to type in cosine of x. So here's my cosine button. I'm sorry you can't quite see. Here's my cosine button. So cosine, there's my x, and I will close that. Now, I'm going to press, I don't want to graph this, because this is a trig function, I don't want to graph this on a standard -10 to 10 window. I'm going to go in and I'm going to say zoom, and notice number 7. Number 7 is trig. So I'm going to choose number 7, and now here comes the graph. And hopefully you'll notice that this particular graph has symmetry with respect to the y-axis. So what does the graph look like? I'm just gonna graph a basic little graph here, just simple enough to be able to see. Oops, that was really bad. Oh, that is so bad. That's a really bad graph. I can erase, but it'll take me forever. Let me erase. Well, not too bad. I don't like that. I'm erasing, and I'm gonna redraw this. So that's a little better. Okay, so I just graphed a portion of the graph, but you can see that this has symmetry with respect to the y-axis. So this is an even function. Okay, I'm not going to use I'm not going to verify this the same way I did this. What I want to do is I'm going to show how when you substitute a pair of values, let's pick an angle measure because your x's are angle measures. With a trig function, the variable x represents an angle measure. So if I choose, let's say, pi over 3, if I evaluate the function at pi over 3, let's see what we get. Cosine of pi over 3. All right, well, if we go to our circle, pi over 3 is here. The ordered pair, square root of 3 over 2, 1/2. So cosine of pi over 3 is square root of 3 over 2. But now I want to evaluate f of its partner, and its partner is negative pi over 3. And how did we go about evaluating negative? How do we know how to evaluate negative angle measures? What is cosine of negative pi over 3? Well, if we resort back to what we did in the first part of this lesson, where we would add 2 pi, I'm going to come right here. I'm going to take my negative pi over 3, and since I want to get an angle that's on our circle, because I don't like negative angles, I'll take negative pi over 3, and I will add 6 pi over 3. And that's 5 pi over 3. So where's 5? That's 5 pi over 3. So pi over 3 is here. We know 5 pi over 3 is in quadrant 4. So actually, ignore that. I'm going to go back up here because here's my pi over 3. Here's 5 pi over 3. And the ordered pair is square root of 3 over 2, 1/2. I know that's small, and I'm sorry. And the 1/2 is negative. So f of negative pi over 3. If I want to evaluate cosine of negative pi over 3, I can evaluate cosine of 5 pi over 3, which is square root of 3 over 2. And if you look at those two values, when we evaluated this function at pi over 3 and negative pi over 3, we got the exact same answer. And if you were to do that with all pairs of angles, an angle and its opposite, you would see that we would get the exact same thing. So cosine is an even function. So since cosine, I'll put it here. hang on just a second. I'm going to write it here. Cosine of negative x will equal cosine of positive x. They will be the same. So cosine is an even function. Okay, let's talk about sine. Well, if I put my graph up here, or calculator up here, let's see what we can come up with. Let's see if I can do a little better. Okay, so I'm going to go back into y equals. I will clear this out, and I will type in sine of x. And I will close it, and then I will graph. So this graph, you have to kind of look at it a little bit closer. This graph, there's no symmetry with respect to the y-axis, but there is symmetry with respect to the origin. Okay, so let's just talk about, let's look at comparing some values to see what that would look like. So if I want to evaluate, let's say f of, let's just go ahead and keep with the same two functions, pi over 3, or the same angle measures. Let's identify what sine of pi over 3 is. Okay, pi over 3, still that angle here. The ordered pair is still square root of 3 over 2, 1/2. So the sine of pi over 3 is 1/2. Now, let's evaluate sine at the opposite of pi over 3, which is negative pi over 3. So sine of negative pi over 3, well, we did the work over here. We know that a coterminal angle, a positive angle measure would be 5 pi over 3. So 5 pi over 3 is here. And the ordered pair is square root of 3 over 2, negative 1/2. And sine of 5 pi over 3 will be negative 1/2. Now, if we compare this value and this value, you'll notice that f of pi over 3 and f of negative pi over 3 have exact opposite values. So therefore, sine is an odd function. Okay? So, and this is true for all pairs of angles, pi over 3 and negative pi over 3. So sine is an odd function, cosine is an even function. So because sine is an odd function, sine of negative x will equal the opposite of sine of positive x. So the key here is these two have opposite signs. So rather than go through this process with all 6 trig functions, I'm just going to kind of close this out here by telling you that if cosine is an even trig function, then so is, you got it, secant. Secant is also an even function, so secant of a negative x will equal the same thing as secant of x. And those are the only 2 even trig functions. These are the only 2 trig functions that have symmetry with respect to the y-axis. Now, in our next unit, that's when we're going to focus on the graphs of the trig functions. But for now, just know that cosine and secant are even trig functions, and their graphs will have symmetry with respect to the y-axis. Every other trig function is an odd function. So that means sine, its reciprocal, cosecant of negative x, will equal the opposite of cosecant of positive x. And then tangent of negative x will equal the exact opposite of tangent of positive x. And then cotangent of negative x will equal the exact opposite of cotangent of x. So we're going to evaluate some trig functions, and we're going to base it on, or use the fact that the trig function is either even or odd. We're going to use that to determine what the value is. So if you'll notice these four examples, they're all negative. And this tool is simply a nice tool to use when you want to or need to evaluate a negative angle measure. So let's just see how that's going to work. All right, so cosine of negative 30. If I want to evaluate cosine of negative 30, I can evaluate its opposite, its partner, cosine of 30, and think about where 30 degrees is. It's there. Its ordered pair is square root of 3 over 2, 1/2. And cosine of 30 is the square root of 3 over 2. Therefore, because cosine is an even function, then cosine of negative 30 will also be the square root of 3 over 2. These two have to have the same value. So if cosine of 30 is square root of 3 over 2, then so is cosine of negative 30. All right. Cotangent. Cotangent is an odd function, but I still want to evaluate cotangent at negative 3 pi over 2's partner. And that partner is 3 pi over 2. Okay, well, let's figure out where 3 pi over 2 is. 3 pi over 2 is here, and the ordered pair is 0, negative 1. So, cotangent of 3 pi over 2 is cotangent's the reciprocal of tangent. And if tangent is negative 1 over 0, that's undefined, so cotangent would be 0. If tangent is undefined, then the reciprocal of undefined is 0. Well, the nice thing about 0 is that cotangent of 3 pi over 2, since it equals 0, there is no opposite of 0, so therefore cotangent of negative 3 pi over 2 is also 0. All right, sine of negative pi over 4. So sine of negative pi over 4, if I evaluate sine at the positive pi over 4, which the angle is here, the ordered pair is square root of 2 over 2, square root of 2 over 2. Sine of pi over 4 is going to be the square root of 2 over 2. Now, sine is an odd function. Okay, so since this is an odd function, the sine of negative pi over 4 will be the opposite of whatever sine of pi over 4 was. So since sine of pi over 4 is square root of 2 over 2, then I know sine of negative pi over 4 will be negative square root of 2 over 2. So we're simply using even and odd functions, the properties of even and odd functions to help us evaluate trig functions that are negative, that have negative angle measures. Okay, tangent of negative 2 pi over 3. We will evaluate tangent of positive 2 pi over 3. All right, pi over 3. The pi over 3 angle is here. 2 pi over 3 is here. This ordered pair would be negative 1/2 square root of 3 over 2. So tangent of tangent of 2 pi over 3. Tangent of 2 pi over 3. Tangent is sine over cosine. Oops, sorry. So this is going to be negative square root of 3. So because since tangent is negative square root of 3, then tangent of negative 2 pi over 3 will be positive square root of 3. Tangent is an odd function, so these two will be opposite. All right, and then one more. Secant of negative 5 pi over 3. So secant of 5 pi over 3, negative 5 pi over 3, let's evaluate secant of positive 5 pi over 3. Well, once again, we have our pi over 3, which is 1/2 square root of 3 over 2. 5 pi over 3 is in quadrant 4, so that's 1/2 negative square root of 3 over 2. If I want to evaluate secant of 5 pi over 3, if I want secant of 5 pi over 3, I need to look at cosine. If cosine is 1/2, then secant is going to be 2. And since secant is an even function, then secant of negative 5 pi over 2 will be the same as secant of 5 pi over 3. So because secant is an even function, then these two values should be the same. So now we have multiple tools for using, or multiple tools for evaluating or finding the trig functions or the trig values of negative angle measures. So that will kind of finish up and wrap up lesson 4 for negative angles.